Hi, hello there. Welcome to Introduction to Classes. On this video lecture, we will be talking about the abstract data types in C++, and that is classes. Also, we will be talking about constructors and the common programming errors. A procedural program consists of one or more algorithms that have been written in a computer-readable language. This type of program, as you have experienced in Programming 1, is especially useful for solving engineering and scientific problems, in which inputs must be processed to produce outputs by using clearly defined steps. In these applications, data is typically entered as character data from the keyboard, and then displayed as character data on a printer or screen. Input and display of program output have always taken a backseat to processing, with a clear emphasis on the formulas and calculations being used. On this topic, let's start with an abstract data types in C++. So an abstract data types is basically software development is labor intensive. Okay, productivity in software cannot be dramatically increased like productivity in manufacturing can. Reusable code components contribute to productivity in software development. An object-oriented approach to software development supports the creation and reuse of the software components. Now, to gain a clear understanding of what an abstract data type is, take another look at the four built-in data types in C++. Still remember integers, doubles, boolean, and characters. Now, in using these data types, typically you declare one or more variables of the desired type. Use them in accepted ways and avoid using them in ways that aren't specified. So for example, you wouldn't use the modulus operator on two double precision numbers, because this operation makes no sense for double precision numbers. It's never defined in any programming language for these numbers. So therefore, each data type consists of both a type of data, such as integer or double, and specific operational capabilities. So in computer terminology, the combinations of data and associated operations is defined as the data type. Okay? That is, a data type defines both the types of data and the types of operations that can be performed on the data. Now, seen in the slide, the integer data type, the double precision data type, and the character data type provided in C++ are all examples of built-in data types, defined by a type of data and specific operational capabilities for initializing and manipulating the type. Now, in a simplified form, this relationship can be described as follows. For instance, you'll have data type equals allowable data values plus operational capabilities. Okay? So therefore, the operations you have been using in C++ are an inherent part of each data type you have been using. So for each of these data types, C++ designers had to carefully consider and then implement the specific operations. Okay? Now, to understand the importance of the operational capabilities, a programming language provides, take a moment to review a list of some capabilities supported with C++ built-in data types. You've got the int, double, bool, and char. Now, this table here lists the minimum set of these capabilities. Okay? So for instance, capability, define one or more variables of the data type. Something like int, a, and b as our identifier. Initialize a variable at definition. So we could have int a equals 5. So we initialize and at the same time we assign value, okay, to a, which is equals to 5. Assign a value to a variable, something like somewhere on your code, you performed A equals 10. Or assign one variable's value to another variable, something like A equals B, wherein the value of A would also be the value of B. Okay? Perform mathematical operations, something like A plus B. Perform relational operations, something like A is less than or greater than, A is greater than B. Okay? And convert from one data type to another, something like A equals int 7.2. Okay? So these are the capabilities of those built-in data types. Now see how all this information relates to abstract data types or ADTs. So by definition, an abstract data type is simply a user-defined data type that defines both a type of data and the operations that can be performed on it. Okay? Now, user-defined data types are required when you want to create objects that are more complex than simple integers and characters. So to create your own data types, you must be aware of both the type of data you are creating and the capabilities you provide to initialize and manipulate the data. Okay? So when an abstract data type has been created, so programmers can use it without knowing how it is implemented internally. Okay, so example would be a date object might include operations for various display formats, comparing two dates, extracting the month, the day, and the year, etc. Okay, so when you say class, this is an abstract data type that defines both data and functions. So from our previous discussion on structures basically deals with member variables or member data. We don't have functions associated with structure. Now in classes, it has the data and at the same time, the functions. So as a specific example, say you're programming an application that uses dates extensively. So clearly, from a standpoint or from a data standpoint, a date must be capable of accessing and storing month, day, and year designation. So from an implementation standpoint, there are several means of storing a date. But from the user's standpoint or viewpoint, the implementation isn't relevant. For example, a date can be stored as 3 integers, one each for the month, day, and year. Alternatively, a single long integer in the form of something like YYYYMMDD can be used. So the date 5/16/8 is stored as integer, say 2008-05-16. So for sorting dates, the long integer format is attractive because the numerical sequence of dates corresponds to their calendar sequence. Okay, so notice that the details of how much operation works depends on how you choose to store a date. It's called data structure and are of interest to you only as you develop each operation. So for example, the implementation of comparing two dates differs if you store date as a single long integer instead of using a separate integers for the month, day, and year. Okay? Now, in C++, an abstract data type is referred to as a class. Okay? So, construction of a class is easy and you already have all the necessary tools in variables and functions. So, what C++ provides is a mechanism for packaging these two items together in a self-contained unit. Okay? So, next, you see how this is done. Okay? Now, class construction. So a class defines both data and functions as I have said earlier. Okay? So this definition is usually accomplished by constructing a class in two parts. So you'll have the declaration section and an implementation section. Now, the declaration section declares the data types and the function prototypes. The implementation section defines the function. So please refer to the video demo, okay, about coding classes on C++. Now, also, we have what you called a method. Okay? Method is a function contained in a class. And also, we have class members, the variables and functions listed in the class declaration section. And the data members, the variables in a class, also called instance variables. So both the variables and functions listed in the class declaration section are collectively referred to as class members. Okay, separately, the variables are referred to as both data members and instance variables. So the terms are synonymous. And the functions are referred to as the member functions. Okay? Now, a member function name can't be the same as a data member name. So when a function is part of a class, it's formally referred to as a method to denote a class membership. Okay? So we already have defined a method earlier as a function contained in a class. All right? Now, by convention, however, the terms class method and class functions are used interchangeably in C++. As shown in the following code example, the declaration section declares both the data types and functions for the class. Okay? So the implementation section then defines the functions whose prototypes have been declared in the declaration section. Okay? Now, the general structure of this form is as follows. So you've got class and then the name. Okay? So you've got private, the list of variable declarations, and public, the list of function prototypes. Okay? So member functions refers to the functions in a class. Class declaration section begins with a keyword class, and the class name should start with an uppercase as the rule of thumb. All right? And of course, don't forget a class should end with a semicolon. Okay, so class name is usually capitalized as convention. Okay, so you've got the access specifiers. So take note, this private and public here, these are our access specifiers. It defines the access rights to variables and functions in the class. It could be private or public. When you say private, class members may only be accessed by class's own functions. So if the function is not a member of the class, then it has no access to it. Okay, since you defined it as private. Now, when you say public, class members may be called by any objects and functions outside the class. Okay, so the functions or the member functions are usually declared as public. Okay, now the private designation enforces data security by requiring access through class functions called data hiding. Okay, so these are the concepts or the principles on object-oriented programming. So generally, all class functions are declared as public. So because they are used to manipulate the class's data. So another term that you will hear on classes would be constructor. So these are functions used to initialize class data members with values and cannot have a return value. So we will be talking about constructor on the next section. Now, as a specific example of a class, take a look at the following definition of the class named date. All right. So this type of class is important in applications where equipment delivery dates and schedules depends on the exact date determinations. Now, to accomplish this task, a number of functions for determining whether a date falls on a weekend or holiday, for example, would still have to be added to this class. Because this definition might look overwhelming. So first, notice that it does consist of two sections. You've got the declaration and the implementation sections. Okay, so this is your declaration here, and then the implementation is at the bottom. Okay, so because this definition might look overwhelming, so first notice, as what I'm saying, again, the two declarations that we have here. Okay, so there you've got the declaration section and the implementation section here. Okay, Now, the declaration section begins with a keyword class, and you've got the class name in here, which is date. So following the class name are the class variable declarations. Okay, these are the variable declarations here, the month, day, and year, and the function prototypes. Okay, so enclosed in a brace pair terminated with a semicolon. Okay, now again, the name of this class is date. So although the initial uppercase letter isn't required, it's used by convention to designate a class. So the body of the declaration section enclosed in a braces consists of variable and function declarations. Now in this case, the data members month, day, and year are declared as integers. And three functions named date, okay, you've got set date and show date are declared via prototypes. Now the keywords private and public here are access specifiers that defines access rights. Okay, so the private keyword specifies that the class members following it, in this case, month, day, and year, can be accessed only by using the class functions or friend functions. Okay, now the private designation is meant to enforce data security by requiring all access to private data members through the provided member functions. So what I'm saying is, this private data here can only be accessed by these member functions. Okay? Now, this type of access, which restricts a user from seeing how data is actually stored, is referred to as data hiding, which we mentioned earlier. So after a class category such as private is designated, it remains in force until a new category is listed. Okay? Now, when we run that program, okay, so we've got the class declaration, you've got the implementation. Sometimes the implementation is written next to the main function. Okay, so in this case, it is just below the declaration. Okay, and the main function here, so you've got the date. So take note that we have created a class named date here. So therefore, we have a user-defined data type, date, A, B, and C. C is initialized to 4/1/2000. So declaring three objects of date. So take note that B was declared as date. So therefore, we have an access to set date because set date is set to be public here. Okay, so take note, public set date. And we could have set date. Okay, so it should accept three parameters, MMDD and YYY here, set that to month, day, and year. Okay, so B.set date, so therefore, that's 12/25/2006. So the date is, okay, so take a look at this. These are the values. Okay, so the date is 07/04/05. You've got 12/25/06, and you've got 04/01/00. This is for A, B, and C. Okay. Now, A.show date, take note that A here was just declared, and the show date value is said to be, show date is this one. So the date is month, day, and year. Okay, so you've got 07, 04, and 05. Okay, so that came from the date here, 7/4/2005. Okay, so that was the first output there, A.show date. Next would be B.show date. So again, you've got B.show date, that is 12/25/06. Okay, so where it came from? You've got B.set date here, setting the date to 12/25/2006. That's why you'll have there 12/25/06. And C.show date. Okay, so basically C was defined here as 4/1/2000. That's why you'll have there 4100 for the output. Okay. All right. Now, the implementation section is where the member functions declared in the declaration section are written. Okay? And the following example shows the general form of a function written in the implementation section. So this format is correct for all functions except the constructor, which, as stated previously, has no return data type. Okay? So the syntax would be return type, the class name, and you've got the scope resolution operator. So this two semicolon or colon here is known to be the scope resolution operator, and then the function name, then the parameter list. And then you've got the implementation. Now, going back to our program here, okay? So basically, this is the function implementation here, okay? So you've got the name of the class, okay? Take a look at the name of the class here, and then the name of the function are the same. So this is a constructor, okay? And it doesn't have the return data type. So basically, the job of the constructor is to initialize values to this member variables here. Now, if in any case that the programmer failed to initialize those values, the constructor takes good care of it. Okay? Now, the second one would be the implementation of setDate here. So we have the return value, void setDate. Okay? So anyway, void function or the void return value does not expect return. So you could have eliminated this. Okay? But in this case, well, you've got the name of the class, the return data type, the name of the class, and the name of the function. So same thing with this. You've got the name of the class and then the name of the function. So this is how we implement the prototypes, okay, for a function. All right. Next. A class simply defines a data type, like what you have shown, date, A, B, and C. Now, it does not create any variables of this data type. The variables declared to be a user-defined class type are called objects. So when an object is defined, memory is allocated for the object and its data members are automatically initialized by the class constructor, as what I'm saying earlier. Now, how about the syntax? So, attribute of an object, this pertains to a data member defined for the object's class. And the syntax would be the object name dot the attribute name. Next would be the method of an object. So, it is a function defined for the object's class. And the syntax would be the object name dot the method name and the parameters. Okay? So, understanding the terminology. So, we have mentioned about class. Class is a programmer-defined data type out of which objects can be created. An object created from a class, also called an instance of a class. The instantiation is the process of creating a new object from a class. And then the state, the particular values of data members of a given instance of the class. And the last term is behavior, the operations that are permitted on an object's data members. We called it behavior. On this section, let's talk about constructors. So a constructor function is any function with the same name as its class. So you have seen from the code presented earlier, we have the class named date. And also, we have the function named date. Okay, so that is a constructor. Okay, so a constructor is any function with the same name as its class. Okay, multiple constructors can be defined for each class as long as they get or they can be distinguished by the number and types of their parameters. So a constructor's intended purpose is to initialize an object's data members, as I mentioned earlier. Now, depending on the number and types of supplied arguments, one constructor function is called automatically each time an object is created. Okay? Now, if no constructor is defined or is written, the compiler supplies a default constructor. In addition to its initialization role, A constructor function can perform other tasks when it's called and be written in a variety of ways. So this section explains possible variations of constructor functions and introduces another function, the destructor. So we have the constructor, we also have the destructor. Okay, so which is automatically whenever an object goes out of existence. That's automatically called. Next. So the following code example shows the general format of a constructor. So you've got the class name and then the class names. Take note, the name of the function and the name of the class should be the same. And then you've got the parameters. Okay? Now, as this format shows, a constructor must have the following: the same name as the class to which it belongs. There is no return data type, not even void. Okay? Now, if you don't include a constructor in your class definition, the compiler supplies a do-nothing default one for you. So the term constructor or default constructor is used often in C++ and refers to any constructor that doesn't require arguments when it is called. So the reason it doesn't require arguments is that no arguments are declared. So as with the compiler supplied default, or all arguments have been given default values. So please see the demonstration about classes on the next video. All right, so for instance, you are given here this program 9.2 here. Okay, so for example, you've got the date, okay, and int that's 7, okay, dd is 4, and YYY is basically 2005. This is a valid prototype for a default constructor. So the name of the function is the same name of the class. So that means if the user did not define the values for the month, day, and year, it will be set to 7/4/2005. Okay? Now, each argument have been given a default value, and an object can be declared as type date without supplying any further arguments. Now, using this default constructor, the declaration date A initializes an object with a default values of 7/4 and 2005. Okay? So when we do something like date A, automatically the values of month, day, and year will be set to 7/4 and 2005, respectively. Now, to verify that the constructor function is called automatically, when a new object is created, okay, so examining this program, okay, so which is 9.2, notice that in the implementation section, the constructor function uses cout to display the message created a new date object with the data values. Okay, and take a look at this 7/4/2005. Okay, so that's what I'm saying. So therefore, whenever the construction or constructor is called, this message is displayed. So because the main function creates 3 objects, the constructor is called 3 times. Okay, so take note, we have declared here date A, B, and C. So that means the constructor will be called 3 times and the message is displayed 3 times. Okay, now although legitimate C++ statement can be used in a constructor function such as cout statement in this program, it's best to keep constructors simple and use them only for initializing purposes. So do not include a cout statement, otherwise every time you declare an object or a new object, it will be displayed. So one further point needs to be made about the constructor function in program 9.2. Let's see. All right. So according to C++ rules, object members are initialized in the order they are declared in the class declaration section, not in the order they might appear in the function's definition in the implementation section. So usually, this order isn't an issue unless one data member is initialized by using another data member's value. Okay? Now, how do we call a constructor or calling a constructor? So as you have seen, constructors are called whenever an object is created. So the actual declaration, however, can be made in a variety of ways. Okay? So something like in C++ style, no, class name, object name, argument values. So C style, you'll have this. So class name, object name equals class name, argument values. So as you have seen, constructors are called whenever an object is created. For example, the declaration date C 4/1/2006. This is used in program 9.2 presented earlier. And it could also be written as date C equals date 4/1/2006. Now, the second form can be simplified when only one argument is passed to the constructor. For example, if only the month data member of the C object needs to be initialized with a value 8, and the day and year members can use the default values, the object can be created by using this declaration. Date C equals 8. Okay? So because the form using an equal sign resembles declaration in C, it's referred to as the C style of initialization. The declaration form in the previous program, which is program 9.2, referred to as the C++ style of initialization, is the form used predominantly in the remainder of this video lecture. So regardless of which initialization you see or you use, an object should never be declared with empty parentheses. For example, date A is not the same as the declaration date A. So the second declaration uses a default constructor values, and the first declaration is no object being created. Okay, so take note of that. How about overloaded in inline constructors? Okay, so the primary difference between a constructor and other user-written function is how the constructor is called. So constructors are called automatically each time an object is created, and other functions must be called explicitly by name. So as a function, however, a constructor must still follow the rules of user-written functions. So therefore, constructors can have a default argument, okay, can be overloaded, and can be written as inline functions. So when say inline functions, the implementation is within or inside the class. We call it inline function. Okay? So recall that function overloading permits using the same function name with different argument list. So based on the supplied argument types, the compiler determines which function to use when the call is encountered. So to see how overloading can be applied to date class, take another look at the class declaration repeated here. Okay, you've got the class declaration. Take a look at the constructor here. Date int 7, 4, and 2005. This is a constructor. We have another constructor here, but the implementation is at the bottom. You've got date long, okay, and then void show date, of course. Now take a look at the implementation of the default constructor here, date 7/4/2005. We can place this, of course, on the implementation section, but for the sake of demonstration, it has been included as part of the class. So we called it inline, okay, function. Okay. So the constructor prototype specifies 3 integer parameters, which are used to initialize the month, day, and year data members. So another method of specifying a date is using a long integer in the form of something like you've got year times 10,000 plus month times 100 plus day, which this form, the date 12/24, okay, so if you're given something like 12/24/1998, that is 1998, okay, 1224. And the date 2/5/2006 is basically 2006-0205. So a suitable prototype for a constructor that uses dates in this form is shown here. Okay, so you've got date long, okay, an overloaded constructor. All right, now the constructor is declared as receiving one long integer argument. The code for this new date function must, of course, convert its single argument into month, day, and year, and is included in the class implementation section. Okay, now the actual code for this constructor is as follows. You've got date, okay, you've got date, you've got data type long, and then you've got YYYYY, MM, and DD. So don't be overly concerned with the conversion code using the function body. The important point is the concept of overloading the date function to provide two constructors. All right. Okay, so the next one would be destructors. Okay, I have mentioned destructors earlier when we introduced constructor. The counterpart of constructor functions are destructor functions. So destructors are functions with the same class name as constructors, but are preceded by a tilde. Okay, so therefore, for the date class, the destructor name is tilde, okay, and then date, and then open and close parenthesis. So like constructors, the C++ compiler provides a default do-nothing destructor in the absence of explicit destructor. So unlike constructors, however, they can only be one destructor function per class because destructors take no parameters and return no values. Okay? So destructors are called automatically when an object goes out of existence and are meant to clean up. Okay, so you've got to clean up any undesirable effects the object might leave. So generally, these effects occur only when an object contains a pointer member. Now let's talk about the common programming errors. So some common programming errors associated with constructing classes are as follows. First, failing to terminate the class declaration section with a semicolon. Second, including a return type with the constructor's prototype or failing to include a return type with the other function's prototype. Okay? Next would be using the same name for data members as for a member function. Defining more than one default constructor for a class. Forgetting to include the class name and scope resolution operator. Okay, you'll have these two columns here. We call that scope resolution operator. Okay, so forgetting to include this in the class name and scope resolution operator in the function header for all member function defined in the class implementation section. So all these errors results in a compiler error message. So you can see that when you compile your program. Now for the summary, on this video lecture, we've talked about classes. So a programmer defined data type from which objects can be defined. So two sections of class definition. Okay, so you've got the declaration and the implementation. The class members are the variables and functions declared in the declaration section. The access modifiers, private access, members which can only be used by the class's own function. Okay, and when you say public access, members can be accessed from outside the class. So usually, the member functions are defined as private, or the member variables are defined as private, and then the member functions are usually defined as public. The constructor, well, it function that is automatically called each time an object is created from the class. So it has the same name as the class but no return data type. A default constructor is a constructor with no required arguments. Only one allowed per class. Okay? But you could have an overloaded constructor. Okay? So constructors may be overloaded. And then the last one would be destructor. So functions that is automatically called when an object goes out of the scope, and only one per class. So most of the time, the programmer do not define destructor because when the object goes out of the scope, okay, then it's done. Okay, especially if you are doing program for the laboratory, so they do not define destructor, except of course when they're doing it for the enterprise. Destructors has no arguments and returns no value. Destructor has the same name as the class name, preceded by tilde. Now, I want you to see the video demo on classes. Okay, so that you can understand better the concept of C++ classes. So that's the end of this video lecture. Have a great day. Thank you for listening and watching.